This is Mr. Precella. I'm going to continue working on this review for the college algebra final exam. And here we're going to start off with multiplying imaginary numbers. Okay, there's, well, really complex numbers. When you have a real number and an imaginary number together, you call that a complex number. So what we're going to do here is FOIL it out, but then after you FOIL it, there's a little rule about I squared. It's been a while since you've seen that rule probably. I squared is -1. So FOIL it out, then replace the I squared with -1. All that's going to do is change the sign of the term that has the I squared. So let's see, starting to FOIL it out, we'd have a 6 minus 18i. First outer, inner would be is that a plus 14i? And then finally last, 7i times a -6i, that's a -42i squared. So we FOIL and then replace the I squared with -1. If I replace that I squared with -1, all that's going to do, -42 times a -1, what's that going to be? Negative times negative, positive. That I squared just changes the sign of the green -42 to a positive 42. Y'all remember that rule about imaginary numbers? And now, this I squared is gone. So combining, let's see, what can I combine? The 6 plus 42 would be a 48. The -18i plus 14i is a -4i. Can I then subtract 48 minus 4? No, those are not like terms. You stop right there. Okay. This is multiplying imaginary numbers. Complex numbers. You FOIL it out like a normal, but when you get the I squared, you have to replace it with the -1, which is just going to change the sign on that green -42 to a positive 42. Okay? So once you do the -1 stuff, that I squared is gone. So 6 plus 42, -18i plus 14i. Now, I think that's the only complex number arithmetic problem that made it on here. You might remember dividing complex numbers when we had to multiply above and below by the conjugate of the denominator. Looks like that's not popping up on this review. Which means what? It's not on the test, right? So, problem number 6. Solve the following quadratic equation by using the quadratic formula. Well, sometimes students say, well, can't we just factor it? Well, if it could factor, then yes, but it's sure not my intention to tell y'all to use the quadratic formula when something can be done an easier way. So, as a general rule, if it says use the quadratic formula, it's not going to be factorable. So, let's see. To use a quadratic formula, the equation has to be in standard form with a 0 on one side. So I'm going to write it as 2x squared plus 10x minus 3 equals 0. And let me go ahead and write out what A, B, and C are. A is 2, B is 10, C is -3. go ahead and lift it up now because I'm not going to be using that 2x squared plus 10x equals 3. Let me go ahead and write down the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. So let's see. Negative b. That would be a negative. B is that black 10. So negative 10 plus minus the square root of b squared. 10 squared is 100. Minus 4 times a times c. Minus 4 times a times c. A is black 2 and c is a black negative 3. All over 2 times a. I always do the stuff I can do in my head. The 2a, 2 times 2, we can all do that in our head. That would just be a 4 there on the bottom. And now, like this problem here, I would simplify the square root first. So let's see what we're going to get out of that square root. The 4 times 2 times negative 3. 4 times 2 is 8. Well, okay, it's negative 8 times negative 3. That's going to be positive 24. Underneath here, I'm getting a positive 124. If you want to punch it into your calculator, that's fine. Let me see. Let's see. 100 minus 4 times 2 times negative 3, 124. Okay. On this calculator here on my phone, there's not that negative key and subtraction key. There's one little minus does both negative and subtraction. Okay. Whereas usually with a calculator, it's just a calculator. They want, okay. Now let's write it all. I'm going to rewrite this. I think I'll do it all in one color. Oh wait, we're not finished. We haven't simplified that square root of 124. Now some of you have the little calculators where if you punch in square root 124, it simplifies it for you, but I don't have one of those. Let's see. So I think to myself, what perfect square will divide into 124? Let's see. 4 goes into it. 4 times 31. Will anything go into 31? Is there any number you can think of that divides evenly into 31? No, 31's prime, so that has to be it. To simplify the square root of 124, I'll think of it as 4 times 31. So what would we have? We'd have a black 2 and a red square root of 31. And that's what I'm about to replace all of this stuff with here. Now writing it all in just one color. We have negative 10 plus minus 2 square root of 31 all over 4. There's two ways to simplify fractions when there's just a single number in the bottom. One way is to separate it, which is what I did on that problem number 4. I put both of these over 60, but here, I think what I'll do the easiest way is just to look at the 3 numbers that aren't under the square root. The 2, the 10, the 5. What number divides evenly into all 3 of those? A 2. I'm just going to go through and divide each one of these numbers by 2. So negative 10 divided by 2, negative 5. 2 over 2 is just a 1. 4 over 2 is 2. So negative 5 plus minus the square root of 31 all over 2 is my solution there. Any questions there? The next one, just working out your review from my math lab. I just printed out the assignment, problem by problem on a different page, which took a long time. I'm surprised, even as a teacher, on the teacher side, there's no way to do that other than just by going problem by problem. And I counted. It took 5 clicks of the mouse for me to print out each one of these problems. I guess it's a bad thing that I'm noticing stuff like that. But problem number 7, we're solving an equation, so our answers are ultimately going to be x equals some sort of numbers. Okay? Now if you're solving an equation, x equal a number. On this one, we have 2 fractions, but both of them have the same denominator. And so what we could do is just multiply through by that denominator, the x minus 2. And let's see. I think I'm going to recopy the problem, spreading it out. So there's the problem. I could get rid of the fraction by multiplying straight through by that denominator, the x minus 2. Now be careful. Every term gets multiplied by x minus 2, including the 9. Don't just multiply the denominators by x minus 2. I'm writing it as x minus 2 over 1 to do that cross-canceling. So what do we have remaining then? We have a 2x equals, is that a 9x minus 18? And here the x minus 2's cancel, so a plus 25x squared. Now, let me go ahead and move this up a little. Well, it's a quadratic equation because we have the x squared there. So let's rewrite it, putting getting it in standard form. To get it into standard form, you need a 0 on one side. I'm going to move the 2x over to the right because I always like the a term, the x squared term, to be positive. Okay, I don't want a negative 25x squared, and if I move everything to the left, that's what I'm going to be getting. So I'm going to move this 2x squared over here by subtracting it. I'm now writing it in standard form. 25x squared, then the 9x minus 2x would be a 7x and minus 18. So I got to factor that. Or sometimes students say, well, can I use a quadratic formula? Yeah, you can use a quadratic formula. Okay? Quadratic formula will solve any type of quadratic equation. Factoring doesn't always work, but as a general rule of thumb, for my class, if it's something that that won't factor, I'll make sure the instructions say use the quadratic formula on a test, so you don't spend a lot of time trying to factor something that won't. Let's see, numbers that multiply together to give 25. There's 1 times 25 and 5 times 5. Numbers that multiply together to give 18, there's a lot of them. Well, not a lot. 1 times 18, 2 times 9, and 3 times 6. Draw my 2 sets of parentheses. The second sign is minus, so that means there's a plus and a minus. And normally I'd start with the 5 and 5, and pair them with the 3 and 6, but I can't help but notice that 25 and 18, if you subtract those, you get a 7. So I'm betting that it's going to be these numbers, the 1 and 25 and the 1 and 18. So let's see, if I go 1 times 25, oops, so 1x times 25x, and 1 times 18. Can I make this work out and give me a positive 7x as the middle term? I'd have a 25x and 18x. If I subtract those, I get a positive 7. So that would mean that 25x would need to be positive and the 8 negative. So plus 1 minus 18. And then set each one of these factors to 0. Set the x plus 1 equal to 0. X equal negative 1. Set the 25x minus 18 to 0. Isolate the x, so you move the 18 over by adding 18. And divide by 25. Are y'all caught up with me? Are there any questions? So you would type in, what, a negative 1 and a 18 over 25. The time of the first test, I thought there was one like this on it. I thought this was about the most involved on the test. Any questions there? You've got to make sure you multiply that 9 by the x minus 2 also.
I thought we weren't supposed to put like ones together, like either like x.
Oh no common factors other than 1. Okay, it's no common factors other than 1. Because everything has a common factor of 1. Like 1 divides into 25 and 18 also. Okay, you're right that when you're factoring, you shouldn't have any common factors other than 1. Okay. Another question? Let's take another break. We'll pick up in a minute.